His talk will be about from virtualization and artificial intelligence to 5G convergence.
All right, so maybe I'll do it in English because we have a lot of English-speaking speakers. So apologies for not doing it in Greek, as I was advised. So just a few things about this presentation. It's inspired by this great book. It's called The Second Machine Age by two MIT economists, Eric Brynjolfsson and McAfee. So these economists, they inspired me for this presentation. So one of the key points of this book is that during the Industrial Revolution, we replaced physical labor with machines. And now we're trying to do something similar, but more drastic. We try to replace our brains with digital technologies. And typically, history has shown that it takes humanity about 50 to 60 years to achieve the maximum productivity out of a new technology. So here's an example from the Industrial Revolution when Thomas Edison introduced electricity to manufacturing. The factories at the time, they didn't realize how to make optimal use of electricity. So instead of having a big steam engine, they thought that they could just replace the big steam engine with a huge electrical motor, and then everything else was the same. And they didn't see any productivity improvements. It took them about 50 years to realize you can just take the cables, the electrical cables, and put them inside the factory and build smaller machines with electrical motors, and you can place them in optimal positions within the factory. Another example of this delay is cloud computing. IBM in the 60s, they introduced virtualization, but we just seen in the last 3 or 4 years the actual materialization of the true benefits of cloud computing. So in the telecom industry, we're still not there yet. This was obvious from the previous presentations. But we're getting there. We're digitizing a lot of technologies. Like when I started, SS7 was the king, right? It was the major protocol. You will talk in telecoms now. It's IP from the traditional MSC, the Ericsson MSCs we had at Intracom as well. Now we're talking about IMS and more like IT equipment. So we have a vision now and a dream for 5G. I'm going to name it digital singularity. And in a nutshell, it's going to be the introduction of brilliant new services at very fast time to market. It's going to be very adaptable to different needs, like from individual subscribers to small sensors and devices inside the building, outside the buildings, all that stuff. And a very important aspect, it should be self-healing, right? It should be able to fix itself when something breaks. So we had about 35 years in the telecom industry. So maybe according to the book I was talking about, maybe we need another 15 years to reach the full dream of mobile telecommunications, right? So 5G is probably getting a step getting closer to that dream. So I believe that there are two key technologies that we need to combine with the wireless part of 5G, right? With the spectrum and the antennas and all that stuff. And one of them is virtualization with NFV. And the second one is not just big data, but artificial intelligence. So just a very small introduction about what is NFV versus the traditional cloud computing that we know of. Cloud computing guarantees you resources. So you're going to get 4 CPUs, you're going to get that much memory, that much storage, that much network. And then you're on your own. NFV does not care that much about the resources an application is getting, but is worrying more about, did I give enough resources and did I put my application in the right spot in the cloud or the fog in order to maintain my SLAs. So there is something called the orchestrator in NFV that it sits on top of the virtualization manager. It collects KPIs from its device, virtual device, like network equipment and stuff like that. And then it tries to maintain latency requirements, performance requirements, et cetera, by optimizing these devices and place them in different spots or giving them more or less resources. So that's the difference of NFV. I'm not going to talk about the benefits. I don't have a lot of time. Now, about what is artificial intelligence? Oh boy, this is a very difficult philosophical problem. So I'm not going to tell you what it is. I'm just going to tell you a few questions that AI algorithms can answer, right? So they can answer descriptive and exploratory questions, like, okay, what is the situation right now? Also, they can provide you with inferential and causal and mechanistic questions, like, when this happened, what is the reason? Like, that would be a causal answer. And if you want to do predictive analytics, then you use the machine learning that a lot of people, they think of as AI. But it's not only that, it's all the other stuff that I talked before. And there's a lot of benefits in putting AI as well. So, right, so where we are now. So right now, we are at a point when where telecom operators, they're setting up different teams. So they have a team with data scientists, and they are the big data analytics team. Then they will have some people from the IT, maybe combining with some network people, and they will give them the task of building a virtualized network. That would be the NFV team. And then we have the 5G team, that they are the traditional network teams, some of them out in the field with antennas about the backhauling and core network and access network and all that stuff. Well, that's not going to work. So the next step that we recommend as Intracom Telecom is, let's make a single team. I don't know what we're going to call them, maybe the digital singularity team, and it will have members and expertise from all the other different teams. So you need IT people there, you need data scientists, you need network engineers as well. So these should all be on the same team under the same management. And then the future, the real benefits will be reaped and the real productivity will be increased when you start putting artificial intelligence as a member of the team. There's a great example. There's an investment group in Singapore that 3 years ago, they decided that when they want to invest, when they want to make a big investment, they would have an AI algorithm. They gave it one vote together with the rest of the votes of the board of directors. And it worked pretty well. There was only one problem. This AI algorithm showed a bias to benefit itself. So it would more often voting for an investment on companies that they were building AI than for companies that they were not building AI. So it had a bias for itself, but it's working very well for them. So, okay, right, these are all great ideas, and so what are you doing about that? So how can you help telecoms go towards that digital singularity and help them out? Well, let me tell you what we're doing at Intracom in that direction. The first thing is that we have built a platform specifically for data science and analytics for the telecom industry. And on top of that, we have created an agile methodology only for data science. So this is a methodology not about development and like IT, agile methods or waterfall methods and like that, but this is only for data science projects and how you can bring the different expertise together with the data scientists and have a very, very high success ratio on building a successful AI algorithm that it will answer the problems you're looking to answer. The second thing that we're doing, we've built an NFV infrastructure and we give it for free. Anyone who wants to start learning about the difference between cloud and network virtualization, they can get it and play around with it. We have built an application on top of it as well. And one example that I want to mention here that we're really proud of, this is the first agent that we have built towards the self-healing process. We call it the Service Assurance Controller. And what it does, it communicates with the different applications that they're running on NFV. It communicates with the hardware infrastructure and sees the architecture inside the CPU. And then it tries to place inside the CPU its virtual network equipment on the optimal place in order to run according to the SLAs that they were given to this controller. And what you're doing there as an administrator, you give the machine the algorithm that we have there, you give it your goals. So you say, this application should run with this latency, with this performance, blah, blah, blah. And then on its own, it starts learning. And maybe there are competing applications as well. It starts learning about the hardware is running on its own. And without asking for advice from a human being, it would change the original configuration given either by the operating system or by the administrator. So this is the first example we have of an AI agent that it could work hand in hand as member of the team that manages virtual networks. So my time is running out, so thank you very much. I was right on time.